Hello, Precalculus student. This video is for Chapter 5.2, Unit Circle and Trig Functions. So unit circle can be used to find exact value of certain special special angles, like the coterminal angles, and also these angles that's related to 30 degree, 60 degree, 45 degree, or pi over 3, pi over 4, and pi over 6. But if there are other angles like 18 degree or 2 pi over 9, we can't find them. But we can use the calculator to approximate them. In the old day, we actually would carry tables. They would have tables of from 1 degree to 90 degrees of cosine, or from 1 degree to 90 degree of sine, and all those, and you look them up. But with the brilliance of calculator, scientific calculator, we can actually just use the approximate value of them. Now, mind you, they are approximate value only. And also there's two input. You can have a degree input if it is really an angle in degree mode, or you can have a radian input, which is have no units. So how do you distinguish those in the calculator? So I have the scientific, decimal.com scientific. In a general scientific calculator, you will have different mode, but let me talk about the decimal first. So if you click radian, anything that you enter is in radian. So we know sine pi over 2 is 1, right? So you see how sine pi over 2 is radian is equal to 1. Make it smaller. It doesn't show there. So the left-hand side, the right-hand side is where the answer is. But if you click here, sine pi over 2 is not 1, because they are thinking of sine pi over 2 degree is this. Okay, so make sure that you choose the correct one. Okay, choose the correct one. And then you have sine, cosine, and tangent. Only sine, cosine, and tangent. If you need a secant, cosecant, and all those, you have to use the reciprocal properties of them. Namely, let's go back to the notes. Namely, if you look at this is sine and cosine only. So we'll talk about. Would I talk about it later? Let me see. I just want to make sure that I do talk about it later. Yeah, I will talk about that later. So for sine and cosine, basically you use a scientific calculator. If you have a graphing calculator or a real scientific calculator, you can use this one. You can try to make sure that you also so turn it on, clear all this. So you want to make sure that your mole is a degree mole or radian mole. So for some scientific calculator, actually they will show up. They will tell you. If not, you go to mole and you make sure that it's radian or degree. By default, it's radian. Okay, then you quit. So you will say sine radian is pi over 4, right? Pi, where's pi? Pi over 2. It should be 1, right? So yeah. Let's actually do cosine 18. I can do cosine. 18 is degree, so I have to change it to degree mole. And then quit. And now when I enter cosine 18, it would be 0.9511, round to 4 decimal places. And here I can change it to cosine 18, 0.9511. What is about cosine? Okay, B. Sine 2.1, but there's no degree here. That means it's radian, right? Radian sine 2.1. So I can use this decimal scientific calculator. I want to do radian, and I want to do sine 2.1. 0.8632. equal to 0.8632, four places. Cosine 2 pi over 9, so it also in radian, 2 pi just over 9, because it's not a special angle, 0.6428, 0.6428. Sine negative pi over x, so you can put input negative because the input can be negative and angle can be negative, and it is there's no degree, so it's radian still. So do negative pi over 8, oh, negative, oh gosh, negative pi over 8, negative 0.3827. 0.3827. It's also nice to play around with, what are the end behavior? Are they really fluctuating? Let's say 1 million. What happened? Do they go to negative infinity? No, they go to a number. Oh, 1 million plus 20. Negative. Okay. 21. 22. Negative. 23. Oh, positive. So it fluctuates between numbers. And by looking at the unit circle, you can see that the highest number it can go is 1. The lowest number for sine it can go is negative 1. So the highest y value is 1. The lowest y value is negative 1 because that's sine. The same for cosine. Cosine is x. Highest y value is 1. Lowest y value is negative 1. They fluctuate over those. So even if you have big input and big output, they don't go into infinity or settle down to a number. So let's look at other trig functions. So this is 5.3. We begin with 5.3. For 5.3, we have done sine and cosine in the previous one with the unit circle. Now we are looking at tangent, cosecant, secant, and cotangent. So tangent and cotangent is easier because it's the value is not directly show up as x and y, but it's the ratio of y over x or x over y. If it's y over x, that's tangent, the sine over cosine, and if it's x over y, that's cotangent. So now, when you divide by a number, x and y could be 0, right? At the axis, they are 0. So it will be undefined if x is 0 for tangent, and it will be undefined if y is 0 for cotangent. What about cosecant? It's just a reciprocal of x and y. And in those cases, because x and y could be 0, so they would have some undefined place. So you would imagine that these function has asymptotes, but sine x, cosine x doesn't have asymptotes. The asymptote is when x is 0 or when y is 0. Okay. So find the exact value of these other trig function for angle from 0 to 360. So what is pi over 6? I'm going to write the draw the unit circle again. Pi over 6 is here. The two numbers are what? With 3 over 2, 1/2, right? For pi over 6. So cosecant is what? Is 1 over y. 1 over y. 1 over y. Let's look at cosecant. It's 1 over y. So our y is 1/2, so that's equal to 2. So tangent pi over 4 is, pi over 4 is here, is root 2 over 2 over root 2 over 2. So tangent is y over x, so it's still exactly the same. So it's root 2 over 2 over root 2 over 2, they're identical, that's equal to 1, so that's equal to 1. Then cotangent pi over 3, I'll draw pi over 3, and I'll write the coordinate is 1/2 with 3 over 2. X and y, so for cotangent is x over y, so it's 1/2 with 3 over with 3 over 2. So the over 2 cancel, so it's 1 over with 3. Rationalize it is equal to with 3 over 3. Okay. D, secant 3 pi over 4. Where's 3 pi over 4? It's this here. It's pi minus pi over 4. And I know the coordinate is negative with 2 over 2 and root 2 over 2. Yeah, you need to build your fluency into, okay, I need to know where the angle is and also write the x and y. Now secant is 1 over x, right? So that would be, flip this over, would be negative 2 over root 2. That is negative root 2. Because if you multiply root 2 at the bottom, it would cancel out the 2. 8 pi over 3. This is not in the unit circle. So I'm going to minus 2 pi from it. So the coterminal angles would be, is the same as tangent what? 6 pi, so 2 pi over 3. So although my input is this, but because they're coterminal, they have the same terminal side, I would just use 2 pi over 3. 2 pi over 3 in the unit circle is this one, right? Oh, it's a higher one here. And the coordinate is 1/2 root 3 over 2. Oh no, it's not, it's negative 1/2 root 3 over 2. Tangent is y over x. So it's root 3 over 2 over negative 1 over 2. Over 2 and over 2 cancel. It's just negative root 3. Secant 7 pi over 6. I know it is 1 over x, right? But where is 7 pi over 6? It's pi plus pi over 6. It's over here. This number is negative root 3 over 2 and negative 1/2, right? The x and y is. So my x is negative root 3 over 2. So flip it over is negative 2 over root 3. Rationalize it is negative 2 root 3 over 3. If you multiply root 3 top and bottom. Cosecant, go back to degree 150. Do you know where 150 is? Is here, right? It's 180 minus 30. So it has the same coordinate as 30, except for sine. What is the 2 number? This one is root 3 over 2, so it is negative root 3 over 2, 1/2. I want cosecant is 1 over y equal to 2, right? Cotangent 315. Remember where 315 is here. Right, because it's 360 minus 45. And this coordinate is root 2 over 2 and then negative root 2 over 2. Cotangent is x over y. X is root 2 over 2. Y is negative root 2 over 2. So that's equal to negative 1. So that's how we evaluate all the trig functions. Of course, if you have a number that are not in the unit circle, a special angle, then you use the calculator. We'll talk about that later. I will go to another topic called fundamental identity. Do I have time to do that? Maybe I don't do the identity. I actually go to the approximate value of other trig function here. Yeah, go do this right away. So again, if I have pi over 10, which is not in the unit circle at all, or like 98 degrees, so how do I do? I would use the properties of the trig function. Secant is actually the reciprocal of cosine, so it would be equal to 1 over cosine pi over 10, right? And this would be 1 over tangent. So these cotangent is pi over 8. Tangent is fine. I just use the calculator. Cosecant is not in the scientific calculator, so that, but it would be 1 over sine pi over 7. So it's just a matter of putting them in. So pi over 10, 1 over cosine. So let's do, this is radian. 1 over cosine pi over 10. 1.05146. 1 over tangent 5 pi over 8. 1 over tangent 5 pi over 8, right? So that is negative 0.4142. And then tangent 98, so I have to change it to degree. Tangent 98, so that will be negative 7.115. Negative 7.115. 1 over sine pi over 7. 1 over sine pi over 7 it will be